This is the README file that you have access to. In this recording, I'm going to add support for JSON while preserving the functionality for formatting in plain format. Before jumping into JSON, I like to separate the concern of calculating the change and formatting plain. In here you notice that the loop does the two things that I just mentioned. So to make it easy for us to separate the formatting logic, just extract a method that is responsible for building the string. Now, by looking at the signature, it's pretty clear that it's dependent on coin and number of coins. So I'm using the IDE shortcut to extract a parameter that will hold the coin and number of coins. So with that refactor, we have a class with a constructor, and it has two getters to get the coin and the number of coins. So extracting that method helps us find out what it is dependent on, and secondly, we could use the IDE to create the parameter object. I'm going to inline it. It has served its purpose for now. Let's run the test. Everything is green. I'm going to show you the class that got built for us, and I didn't have to write any line of code for coin count. The IDE created the getters as well as the constructor that initializes the initial values. Let's commit the change. We already ran the test. So when you do this Kata on your own, I suggest you have the meaningful comment. I did not do that for the sake of saving time over here and focus more on the refactoring. So I bring the output variable a little lower in the method because I try to reduce the distance between a variable where it is used and where it is defined. And now I'm introducing a list which will contain all the counts. Then we'll be one step closer to separating the seam between calculating the coins and building the string. There it is. So we have two for loops with independent responsibilities for each for loop. So now we can easily extract a method out which does one thing, which is building the plain format. And it's not all the logic for plain format yet, but we are getting closer. So the nothing is a special case that's at the top of the method, and I believe we could handle that within this method by just checking whether it's empty string or not. So the test ran successfully, so we can remove the if statement from the top of the method. Run the test again, commit. Next thing I would like to do is introduce a class that is responsible for printing the plain format. I'm defining that as a parameter so that I can use the IDE to move the method to that class. As you can see, uh, now it's easy to press the F6 for move, and there it is. It's a good time to commit. So now we are not using the enum that's being passed in. And the way we could use the enum is we can just push the knowledge of the plain printer into the enum itself. So let's try to do that. It's the same strategy, defining enum as a parameter to the method, and then I move the method to enum. Run the test. Everything goes green. Let's commit it. Since we're looking at the print type enum, we could try to refactor it a little more so that the construction of the plain printer is much more closer to the plain enum. And the way I'm doing it here is by extracting a field variable, and that's being initialized in the constructor. Now I'm going to extract that as a parameter to the constructor so that the plain enum and JSON enum happens to construct the same plain printer. But everything is still green. We are not concerned about JSON yet. So everything works, and this class is purely dependent on the enum. It does not know whether the instance of a plain printer is being instantiated. So this class really supports any format going forward and is really close for modification from that aspect. Let's clean up this class a little more so that the public method clearly tells you that it's doing those three steps. The first step would be converting the string input into the cents, which is integer, and then calculating the individual coin counts. And the third thing it's doing is the formatting, which is really being delegated uh, to the print type enum method. All right, let's take our focus back to our plain printer. Now that we know that JSON format is coming pretty soon, let's move towards a strategy pattern. And let's rearrange our code, and we know that there will be some base class or base interface that will have the print method. And I'm trying to pull up the print method. It doesn't have any base class or base interface, so I'm going to introduce the interface right now. Let's call that printer. It is not a specific format, but just a generic interface that will do any kind of printing. Now that we have the interface, we can easily use the IDE to pull up this print method into the interface. So it's a good time to run the test and commit it. It's a very small step, but it's pretty significant. So we could start using our printer interface right here, but nothing is forcing us to do it yet. Um, Basically, when we start working on the JSON, it'll definitely force us. So let's not do any more changes to our code yet. So I've done that in one place, and let's move the focus back to the plain and make sure that all the logic of the plain formatting is in one place. Here I'm moving the printing class into a package, and that's something that you need to keep an eye on as you create classes. Let's not put it in unrelated package. So that's again another aspect of the single responsibility. Now let's look at the printer, um, the plain printer, and see where the logic is for uh, formatting the string. And we can see that the coin has some functionality that is very specific to the plain printing and is being invoked from our plain printer. So what we could do is we could bring it into the plain printer by inlining the method. So there are some warnings, and let's go ahead and see if it can be addressed very quickly, otherwise we'll reset it back. So it looks like it's just a matter of making those two methods as higher level of visibility, and yes, that was it. So let's commit it. And I'm extracting those little methods with the intention of inlining those output for singular and output for plural methods, because definitely that is related to the plain printing. And it may turn out that some other formatters might need the same logic. Maybe at that time you could refactor it and extract the duplication. But for now, we know JSON won't be caring about that specific kind of formatting. Let's go back to our plain printer. And at this point, we could leave as is and move on to JSON printing, and we would still have the strategy pattern. But let's spend a couple minutes here because visually it looks like there's some duplication going on in there in a couple methods there, especially the single count and the plural count method. They look very similar. So I'm trying to rearrange this to see how we can extract that duplication out. So these methods are doing two things. One is determining the name, whether it's singular or plural. The second aspect of that method is appending a space after that, which is a delimiter. So the delimiter stays the same whether the name is plural or singular. So maybe that's the part that we need to extract out and just focus on getting the right name. So I'm rearranging the singular count so that it looks similar to the plural count here. Don't forget to commit often. And of course, make sure the tests are green before you commit. Let's inline these methods because looks like we are appending both singular and singular. Oh, sorry, appending the plural and singular, but really one of them is effective at one point. So we could get away by doing only one append, although the statement on line 30 would become longer, but that's just temporary. Let's extract that little logic that's going on inside the append. And then I'll try to separate out the delimiter idea from that statement. One thing we could do is just pass the coin count to it, and the way I'm refactoring that is using the extract parameter or the parameter object. And in this case, we already have the class called coin count, and the ID will put in place automatically. So we already have a variable called coin count. We can use that there. And the other thing comes to my mind is we could move the coin name method. Maybe we could rename it, but that method could be moved into coin count. But this method already has some more logic beyond the name itself. So let's extract that space or the delimiter concept from here. There might be a better way of doing it, but right now I'm choosing to just cut and paste, which could be dangerous, but it's a small step. We'll run the test, make sure we didn't break anything. Yep, and commit it. Now the coin name class is or the method could easily be moved out of here, and right now as you can see it got moved into the coin count, and it's pretty self-contained. All it does is looks at the count which it owns and decides on the name based on the count, whether it's plural or singular. So this has nothing to do with the formatting, but purely based on the count, and it figures out which name, and both are the field variables, or at least responsibility of the coin count. So I'm okay putting that logic in here. And going back, Well, before that, let's commit it. Now coming back here, this looks a little better, but still I do see that the appending is doing two things. So let's separate that out. So now it's a little better where you have those two kinds of delimiter, although those two kinds of delimiter are both spaces. Um, you could, for clarity purposes, you could extract constant and say one delimiter space is about the space between count and the coin. The other one is between the counts itself. So I think I'm not going that far yet, but that's an option if you think that helps. So there it is, everything is green, let's commit that. So that if statement, maybe we could convert that into a guard statement so that we don't have multiple statements within the if. When you have those bunch of statements under the if, it kind of slows you down when you're scanning very quickly what's happening. So in this case, I'm okay putting it in one line because it's a guard statement. It consists of one check and one statement after the return. So now rest of the method flows easily and returns on line 30. So let's go ahead and see what else we could do to simplify. I'm just looking at the warnings and trying to see if I should accept the suggestion that IDE is giving me. In this case, I'm choosing to get rid of the string builder as the IDE suggested me. That's good. Let's inline that and commit that. So this class looks much better now. I think we can switch our focus onto the JSON. And the way I would introduce JSON is by test driving it. Let's commit this. In JSON, I know we have a test that is ignored right now, but let's leave that ignored. And let's write our own JSON printer test that'll build our JSON independently, and then we'll hook it up. Since we have a package pertaining to specific printing, let's put this test in the print package. The first test I'm thinking of is a pretty straightforward test that will force our JSON printer to implement our interface and also have the entry method built up. So I'm going to define a variable called printer, but then on the right hand side I'm going to instantiate a JSON printer, which doesn't exist yet, but what you'll notice is the IDE will automatically detect that JSON printer needs to implement printer, um, and then we can use the IDE to implement our method right there. And obviously it'll implement as a default implementation, which will return null. And let's not do any more than required. So coming back to our test, we will expect that the 0 cents, which is basically no coin counts passed into the print method, should return me an empty JSON object. Again, I'm not building the final functionality where you expect the full JSON, including all the coins that we know of when there's 0 coins. So that responsibility is for the calculator or the higher level, but in this case I'm saying if I am passed an empty list, I'm going to return you an empty object. And pretty simple to pass that, but we have done a lot here. We have brought in the JSON printer into existence, which implements printer and has a method that is implemented and works for 0 counts or no counts. Let's commit that. And the refactoring cycle, which we should not forget, I'm trying to clean up our test here by just accepting some of the warning suggestions. And there's green, so let's check that in. So the next test I'm thinking of is let's bring in at least one count. And it doesn't matter which coin it is, but let's use pennies and focus on getting the name right in this case. So the expectation would be that it'll be plural, name of the penny, and the name is regardless of how many uh, coins are there. So in this case, I'm just using 0. And let's see if we get the expected error. All right, that makes sense. We are returning empty object, but we expect pennies of a 0 count. So let's focus on just the name part. So let's extract the first coin in there. I don't want to loop yet because the test is not forcing looping yet. So let's plug the first element from there and extract the coin. Looks like we don't have the coin extractor yet. So let's put that back in there. I know it was there at one point. Once we have the coin, we can get the name from it. And it'll always be plural, or at least for this test case, it'll be plural. I'm going to hard code the count and get that plural. That should go green. Let's see. Nope, it does not because I missed the index out of bound. So sometimes I catch this before or sometimes not. So in this case, it's pretty easy. Just write the guard statement up there and return when collection is empty or the list is empty. There it is. Everything is green, committed, and then we'll think about what we can refactor and then move on to the next test. Looks like we could extract a smaller method here. Usually I extract a method that takes one item from the list and operates on it. And then when we uh, go in and do the looping around the collection, then the method could be reused. In this case, I've extracted the method that takes the whole list, but that will get refactored pretty soon. Let's clean up our test here. We could define a field variable for the JSON printer. I think that's good enough. Let's triangulate on the next step of getting the count correct. Small refactor there. Let's commit it. So if we do the 2 cents, we'll be able to generalize the count aspect. Right now it's hard-coded as 0 in our production code. And it'll also document that the pennies will always be pennies. It's will never be singular. In this case, I could have done more than one penny too, just to document that aspect of it. So we already have this construct over here, so I'm going to just replace that 0 with the method that already exists on coin counts. I'm still hard coding the index 0. Right, let's refactor. So let's extract the method or the parameter out and then operate on one element in the list at a time. There. As you can see, we are staying green or using the IDE for refactoring, so there's less chances of running into compiler errors and figuring out how to fix those. I could have done a little bit differently. I could have reused the coin count variable, but we'll fix it pretty soon. So we don't need two parameters of coin count there. We can remove it. And then I might have to take things in my hand and should be pretty quick. Yep, screen. So now we have kind of two levels of abstraction. One is saying that build the count string, and then that in turn calls another method that gets the name and gets the count coin directly from the coin count and builds the string. All right, that looks good enough. I think it's time for us to force ourselves to loop. And again, it doesn't matter which coin it is, we just want two coin counts. Or I could have done three, but the idea is to force ourselves or make the code a little more generic instead of hard coding the first index. Oh, I think I got the test wrong. So that's the advantage of having a mindset of checking whether the test is failing the right way or not. So I noticed that I'm creating the instance of quarter and penny a couple times. Really, there's no difference between one instance and the other instance in the whole system. So I could refactor that out as constants, but let's continue with what we have right now and focus on this test. So it's failing correctly, and I think it's time to loop. Could do a for loop, uh, which idea would help me, but I think let's try the streaming, which I've gotten more used to nowadays. So because I have this method that was extracted earlier, it's pretty easy for me to just invoke that on every item in the list, and then we know how to join every item. It'll be just comma and space. That's how our JSON looks like in the expectation. I won't worry about the variable name collect yet. Let's make sure we get back to green. There it is. So let's commit it, and then we'll look at some variable names and stuff. Just accepting the suggestions there. I could inline, or maybe another method could come out. We'll see. So one thing that's remaining here is the special case of nickel. That is never plural. So let's force that in here now by having a fitting test. I'm going to copy paste in this case and make sure I don't make any mistakes while I'm modifying this piece of code. We know it'll always be one nickel, so I'm just having the test same as that. But if you notice, this particular JSON printer doesn't care what is the count of nickel is. Somebody could pass in multiple nickels and it'll just print singular nickel. Um, if this JSON printer used out of the context of change maker, maybe uh, it might become plural, but for now I think we can limit to the requirement that we have in hand. So the way I'm deciding to make sure it's a nickel is just checking the instance of it. If I had a kind of a constant of nickel, I could have checked that it's same as the nickel constant. There it is, it's green. Let's commit that and then look at it. So this method doesn't need the coin count, it just needs the coin. So let's promote that as a parameter. So IDE refactored and removed the coin count as a parameter. Now it reads spread better, but still the instance of check doesn't show the intent. So let's extract it to make it more intent revealing. So all we're doing is checking whether it's a nickel. How we are doing it could vary, but important is what we are doing it there. So before we do anything more, let's run the test. Yes, it's all green, and I'm going to go ahead and commit it. All right, this method is good enough, but still there are two major things going on. The first thing that I highlighted could be a method that could reveal the intent of building the whole coin counts strings, and then we are prefixing and suffixing it with something else before we return back. So it's kind of, this one reads better than before in my opinion. I think JSON printer is good now. It's I think covering all the scenarios we need. Let's switch the focus back to enum. To make this aware of JSON printer, we'll have to modify that. So, but obviously we're going to write the test first. That'll force us to make that change. So the scenario I'm thinking is pretty simple. Some coin count, and then we'll verify the JSON was created. And remember, the enum is not knowledgeable about how exactly the formatting is happening. So I don't like to hard code my JSON format in this class. It would be okay to do it, but what it'll do is it'll make it a little brittle when and if the JSON format changes. Not only your JSON printer test would change, but also the enum test would change. So I'll show you how I do it here. So now I need an expected value here. So that's the variable. And I'm going to invoke the real JSON printer that we know exists. And let's ask that to build us the string. And the string that we get back from this JSON printer should match however the enum is getting the value. Let's make sure it's failed for the right reason. Yep. So it is behaving that way because we're using the plain printer. Now it's quite a simple change here. I just have to instantiate the JSON printer and that should, oh, okay. So that's forcing me to update my constructor parameter. I'm trying to see if IDE would do it for me, but looks like it's easy enough to do it manually here. And that's green. So that's about it. So now enum can handle JSON and plain. So obviously you do TDD for adding a new functionality, but when you are refactoring, you end up in a situation like we have in here, where we have plain formatting going on via the enum, but it does not have a corresponding test in it. And it's being covered by a higher level test, but we do want to have a unit test closer to where the logic is. This is pretty similar to JSON, except that it'll be using the plain printer. So I would like you to look at the other tests that we have refactored and moved around the methods to new classes or other existing classes. So I haven't done this in this demo, but I would want you to look at every class when you're done and move the test appropriately. And you might see that you'll delete some tests at a higher level because you don't need that detail when you have the detail closer to the class that is doing the job. So the coin count here is not very interesting for the test that we want. So I'm going to initialize that in the setup method. What is really interesting is you are getting the appropriate format back. So I think that's good enough. So I'm going to run the test and commit it. Now the moment of truth. So we had a couple ignore tests in the change maker test class, and we expect those ignore tests to go green once we run those. So let's remove the ignore tag. Yep, that's green. So I'm doing it one at a time just so we know what failed. So that should be, yep, one final commit, and thanks for watching.